Welcome to The Explainer. Today, we're diving into one of the biggest challenges in AI right now. How do you actually get a smart, conversational agent to millions, even billions of users, without the whole thing just falling apart? Well, the answer lies in solving a really fascinating paradox. Okay, let's just jump right into the deep end. At the heart of this whole problem is this fundamental clash, this mismatch between how an AI agent works and how the cloud infrastructure that's supposed to run it works. You've got the smart AI on one hand and the massive system needed to serve it to the world on the other.
And this slide really breaks it down perfectly. Your AI agent, it's stateful. Think of it like talking to a person. It remembers your name, what you talked about yesterday, your whole conversation history. That's what makes it feel intelligent. But the cloud containers you need to scale it up are stateless. They're more like a vending machine. Each time you use it, it's a brand new transaction. It has absolutely no memory of you. In fact, it's designed to forget instantly. So you see the massive problem here. How do you scale something that needs to remember on a system that's literally built to forget?
So the solution to this puzzle is just a beautifully elegant strategy called a cloud-native approach. And it all revolves around two really simple but powerful ideas that let us have our cake and eat it too.
Okay, first up is what we call an image. The best way to think about this is as the master blueprint for our AI. It's a perfect, read-only package that has every single thing the agent needs to run. All the code, all the dependencies, all the settings. It's like the agent's entire DNA frozen in a perfect snapshot. Then, we take that image and we use it to launch a container. Now, this is the live, running version of the agent. So if the image is the blueprint for a house, the container is the actual house itself, fully built, lights on, electricity running. It's the room where the agent actually does its work and its thinking. And here you can see the whole workflow, which is just brilliant. You build that master blueprint, the image, just one time. Then you can use it to run a container. And here's the real magic. Because that image is a perfect template, you can spin up thousands or even millions of absolutely identical containers from it almost instantly.
So this brings us to the big leagues, handling millions of users. That ability to instantly replicate containers, that's the secret sauce. That's how you manage planet-scale traffic. A million users show up at your door? No problem. You can create a million identical rooms for them to talk to the AI just like that.
But that brings up a really important question, right? You don't want a million containers running if only, say, 10 people are using your app. That would be insanely expensive. So, how do you automatically create and destroy these containers exactly when you need them, and not a second sooner?
Well, this whole process is managed by something called auto-scaling, and there are really two main ways people think about doing it.
Now, this is a really crucial point. The old way is resource-based scaling. It's totally reactive. It waits until a container is, let's say, 70% full, and only then does it start building a new one. You can probably see the problem. If 1,000 users show up all at once, most of them are going to be stuck waiting in line. But the new way, event-based scaling, is proactive. It sees the event, 1,000 users are logging in, and it builds all the rooms they need before they even get there. For massive global applications, this is the only way to go. It's the gold standard.
Okay, fantastic. So we've solved the scaling problem. We can now create millions of identical stateless containers whenever we want. But wait a second. This brings us right back to that original paradox, doesn't it?
I mean, if every single container is just a fresh vending machine with total amnesia, how on earth does the AI remember your name? Or remember the last thing you said just a few seconds ago?
And the solution, which you see here, is just so clever. It's simple. You don't store the memory, the state, inside the container at all. You just offload it somewhere else.
So here's exactly how it works. Your entire conversation history gets stored in a super fast external database. When you send a message, any available container can pick up the job. It instantly pulls your whole chat history from that database, figures out a smart reply, and then, this is the key, it saves the new updated conversation right back to the database before it disappears. The container itself remains perfectly stateless, just a temporary worker, while the memory, the important stuff, lives on safely somewhere else.
So what's really important to get is that this architecture doesn't just solve some technical problem. No, it fundamentally changes what an AI agent can even be. It really opens up a whole new frontier for what's possible.
Because think about it. When you can build an AI agent that is infinitely scalable and totally reliable, it stops being just a simple chatbot. It becomes something much more. It becomes the equivalent of a digital employee, A digital FTE that you can deploy to handle incredibly complex, mission-critical tasks 24/7 without ever getting tired.
We're really seeing this incredible evolution happen right now. We started by building single agents for simple little tasks. Now we're building scaled services that can help millions. But that next step, that's creating entire digital workforces, orchestrated teams of these digital employees that can run entire business functions all on their own.
And that kind of leaves us with a final, pretty mind-bending thought. If we figured out how to build one perfectly scalable, perfectly reliable digital employee, what happens when we start building and orchestrating whole armies of them? What could a company run entirely by AI actually accomplish? The possibilities are just staggering to think about.